our new technique for graphing square roots, right? We have a square root of x plus 4. Old technique is draw your square root graph, move 4 to the left, no problem. The new technique says if you can draw the inside graph, and it was drawn here in red, can you label the points where it's 0 and 1? Those are going to be important because when you square root those, they're going to stay the same. That's based on this idea, right? The only place where you have a same number is 0 and 1. So if you graph the inside and the points stay the same, that's going to be at 0 and 1. Then anytime your y values are bigger than 1, for example, you can even find a nice point, like here, my y value is 4. So when I square root that, I'm going to get 2. If you find any nice points on the graph on the inside that you can square root, you can label them. But you will find that whenever your y values are bigger than 1, your new graph has to be less than the original graph. And that's based on this idea. Anytime you put in a number bigger than 1, when you square root it, the answer will always be less. Square root of 25 is 5. Square root of 100 is 10. Anytime I square root a big number, my answer is always going to be less. And so that shows up on a graph that your square root graph is below because it's less than the original graph. But anytime you do a square root between 0 and 1, your blue graph will be slightly above your red graph. And only slightly above, because it never goes past 1. It will also be a decimal, but it will be bigger. And that was based on the idea that we saw here at the bottom with a bunch of examples that we found. We found a whole bunch of square roots where the answer was bigger than what you started with, but we found out that that only happened when the number was between 0 and 1. And so this creates a new technique. It's a new technique for graphing square roots. Okay? Personally, if you just had the square root of x plus 4, I would hope you still used your transformations and took your square root graph and moved it 4 to the left. Okay? But it wouldn't be hard to graph the inside, which is just a straight line, and then draw the square root after that. And in fact, sometimes, for example, this second one, if you use transformations, you might have made a mistake. The mistake that people make in the second one, if they're using transformations, is that you have a horizontal reflection and a horizontal translation. Do you remember that it has to be in factored form? So you have to horizontally reflect and then move 2 to the right. With the new technique, you don't have to worry about forgetting that. How do I graph negative x plus 2, which is in red here? Well, that has a y-intercept of 2 and a slope of negative 1. This is what it looks like. Is it easy to find out where it's equal to 0 and where it's equal to 1? Not bad at all from the graph. Notice that when your red graph, when the y values are bigger than 1, the blue graph is below. In fact, you have a nice point right here. Here the y value is 4. What's the square root of 4? It's 2. So if you have nice points, you can label them right away. And the spot between 0 and 1, notice that the blue graph is slightly above. So this is what we're going to be doing in this unit. We are going to be taking new graphs and graphing square root graphs of them. Not just ones that we did in transformations, but you're going to be able to square root parabolas, square root cubic graphs, log graphs. You can put any graph that you can graph already, you are now going to be able to graph the square root of that. You're like, yay, I've been waiting so long for this. Okay? The key things, and we can highlight them on the top of this page. So I'll pull up my highlighter. Okay? 0 and 1. Those are important points to find, because they're going to be the same. When you square root 0, it's 0. When you square root 1, it's 1. So if you can find out where the inside function is 0 or 1, those points are going to be the same. And because they're same, they're called invariant points, because they don't vary. Okay? The second one, we can write between 0 and 1, y equals the square root of f of x is above the graph of y equals f of x. That's what the second bullet is saying. If your y values, I guess maybe we should put that in there, y values between 0 and 1, then your graph of the square root, the square rooting between 0 and 1 always gives you a bigger number. The next one is saying that y values above 1, y equals the square root of f of x, is below y equals f of x. Because when you square root a big number, you get a smaller number. And we didn't really talk about this, but you know that you can't square root a negative. So if we look back at the graphs that we had at the beginning, any graph, any part of your graph where you were negative, your square root graph does not exist. Look at the lines that we just did, right? Here, highlighted for you. Here the red graph is negative. And notice the domain of your square root doesn't go that way. Your square root graph started at 0. There's an arrowhead on this side, but not anything on this side. And then the second one. Right? Here, my red graph is negative. My square root graph does not exist, because you can't square root a negative. So with these characteristics, 0 and 1 stay the same. If the y values are between 0 and 1, your square root graph is slightly above. If the y values are bigger than 1, your square root graph is always lower. And you can never square root a negative. And with this, we can be given any graph, or we can graph anything we know, and we can do the square root graph. So to start off with, they're saying, we're not even giving you the equations, we're just saying the original equations were graphed. What does the square root of that graph look like? Well, we go through those key ideas. The key ideas are that wherever the graph's y value was 0, and wherever the graph's y value was 1, those points stay the same. Square root of 0 is 0. Square root of 1 is 1. Are there any other nice values you could square root? Yes. Square root of 4 is 2. That's a nice point to put on there. And technically right here, can you see that right there you would have 9? And the square root of 9 is 3. So technically, I'd have a point there. And this is saying that any values that the red graph is bigger than 1, your blue graph has to be smaller than the red graph. And any points between 0 and 1, when you square root a number between 0 and 1, you always get something bigger. So we graph the blue one slightly above. Okay? I'm going to show you some common mistakes. Slightly above does not mean you're allowed to go back in time. This is over-exaggerated, but wrong. Here is slightly wrong, but still wrong. See how that one went back in time? It doesn't exist less than -2. So sometimes it's going to be you're going to have very little space to be above. You also can't be above and higher than 1. It's another mistake. So sometimes you have very little room to be above and still 0 and 1. Sometimes you might even, best you feel like you can do is just draw it like right on top, because you don't want to over-exaggerate it. That would be fine. So just slightly above. Second example. Okay, we look at 0. That's where y is 0. We look at 1. That's where y is 1. Technically, there's no other nice point. I mean, I could extend it, right? I could extend it to there, and then I could say the square root of 4 is 2 would be about there. Between 0 and 1, this part has to be slightly above. And then it's going to be below afterwards. Questions for practice are number 5.